In this video, we are going to solve two more problems which are a bit complex in nature. So we are going to apply the sum to product or product to sum formula here. So please pause the video and write down these questions and give it a try yourself so that you get a chance to apply the mind and arrive at the proofs. So please pause the video now and give it a try yourself, and you can come back and watch the entire solution. Let's start with the first one now. In the first question, the information given to us is sin A plus sin B is equal to square root of 3 times cos B minus cos A. Using this information, we have to prove that sin 3A plus sin 3B is equal to 0. So let's see how we can use this information. So sin A plus sin B is equal to square root of 3 times cos B minus cos A. I'm going to apply the sin C plus sin D formula here, which is 2 sin C plus D by 2. So in this case it is sin of A plus B by 2 and cos of A minus B by 2, which is equal to square root of 3 times. So this is cos C minus cos D, which is 2 sin C plus D by 2. So this is sin B plus A by 2 and sin of D minus C by 2. So that's a unique formula we have learnt in the previous videos. So now let's cancel out the value 2 here, and we can write this as sin of A plus B by 2 cos of A minus B by 2 minus square root of 3 times sin of A plus B by 2 times sin of A minus B by 2. This is equal to 0. Now the common value between these two is sin of A plus B by 2. So we can rewrite this equation as cos of A minus B by 2 minus square root of 3 times sin of A minus B by 2 multiplied by sin of A plus B by 2 is equal to 0. Now there are two parts to this equation. So let me show you that either this part will be equal to 0 or this part is equal to 0. Only then we get this entire equation to be equal to 0. So what we can write is, so there are two cases. So case 1 is sin of A plus B by 2, this is equal to 0. So when is sin is equal to 0? Sin 0 is equal to 0. That means when A plus B by 2 is equal to 0 and when A is equal to minus B, that is when this part of the equation becomes equal to 0. Now let's try case number 2. So case 2 is when the first part, which is cos of A minus B by 2 minus square root of sin of A minus B, this is equal to 0. So if we solve this equation, we would get tan of A minus B by 2 is equal to 1 by square root of 3. So tan 30 or pi by 6 is equal to 1 by square root of 3. So that means when A minus B by 2 is equal to pi by 6, or when A minus B is equal to pi by 3, in these two cases, this equation will be equal to 0. Now let's apply this value A is equal to minus B in the required proof. So what should we prove here? So we have to prove that sin 3A plus sin 3B is equal to 0. So sin 3A plus sin 3B is equal to 0. So in case number 1, let's apply a is equal to minus b. So this will be sine of minus 3b plus sine 3b is equal to 0, and sine of minus x is minus sine x, so we can cancel this out, and this equation is true for case number 1. Correct? Now let's try case number 2. So we have sine 3a plus sine 3b is equal to 0. What is case number 2? We have to apply a is equal to pi by 3 plus b. So I'm just changing this equation. So a is equal to pi by 3 plus b. So this happens, how can we change this? So this is sine of 3 times pi by 3 plus b plus sine 3b. So when I multiply this, I will get sine of pi plus 3b plus sine 3b. Now pi plus 3b, this is in the third quadrant, and in third quadrant sine is negative. So this will be minus sine 3b plus sine 3b. We can cancel this out and we would get answer as 0. So in both cases, case number 2 and case number 1, we are able to prove that sine 3a plus sine 3b is equal to 0. Now let's try the second one. In the second question, the information given to us is sine of x plus a by cos of x minus a is equal to 1 minus m by 1 plus m. Using this information, we have to prove tan of pi by 4 minus x multiplied by tan of pi by 4 minus a. This is equal to m. Now let's see how we can use this information. We have sine of x plus a by cos of x minus a is equal to 1 minus m by 1 plus m. So whenever we have these kind of questions, so in the previous video we have used a rule of ratio called Componendo Dividendo. So this is very useful when we have a format which is a by b is equal to c by d. So we have that here, which is a by b is equal to c by d. In that case, we can apply the rule which is a plus b by a minus b is equal to c plus d by c minus d. So let's apply that here. So our equation would change to sine of x plus a plus cos of x minus a, this divided by sine of x plus a minus cos of x minus a, which is equal to c plus d. So it will be 1 minus m plus 1 plus m divided by 1 minus m minus 1 plus m. So let's simplify this now. We would get sine of x plus a plus cos of x minus a, this whole thing divided by sine of x plus a minus x cos of x minus a, which is equal to, so we can cancel the m here. We would get 2 divided by minus 2m. So this is equal to minus 1 by m. Okay, now the left hand side here is of the format sin c plus cos d, and denominator here is sin c minus cos d. So we don't have any formula that we can apply when it is a sum or difference of sine and cos. So what we can do is we can change this cos to sine by applying the rule of sine of, let's rewrite this as sine of pi by 2 minus x minus a, because sine of pi by 2 minus x is cos x. Similarly, let's apply the same logic in the denominator. We would get sine of x plus a minus sine of pi by 2 minus x minus a, and this is equal to minus 1 by m. Now we have the format of sin c plus sin d and sin c minus sin d in the numerator and denominator. So we can apply the formula now. So it is 2 sin c plus d by 2. So it is x plus a plus pi by 2 minus x plus a, this thing divided by 2, and cos c minus d by 2. So this is x plus a minus pi by 2 plus x minus a, this whole thing divided by 2. So that is our numerator, divided by the denominator here is sin c minus sin d. So that would be 2 cos c plus d by 2. So it is x plus a plus pi by 2 minus x plus a divided by 2, and sin c minus d by 2, that is x plus a minus pi by 2 plus x minus a, this divided by 2, which is equal to minus 1 by m. Okay, now what we can do here is cancel out the 2's that are common. Now let's simplify this equation. So we would get sine of, so we can cancel out x here, we would get 2a plus pi by 2 divided by 2, 2a plus pi by 2 divided by 2, and in cos we can cancel out a here, so we would get 2x minus pi by 2 divided by 2, denominator would be, cancel out the x here, cos of 2a plus pi by 2 by 2, and this would be, cancel out a here, 2x minus pi by 2 by 2, this is equal to minus 1 by m. Okay, now let's simplify it further. We would get sine of, we can, when we solve for the common denominator here, we would get pi by 4 plus a times cos of, okay, so this is unique here. So instead of writing it as 2x minus pi by 2, we can consider minus 1 as a common factor. So cos of minus x is cos x. So let me write it. Cos of minus x is equal to cos s. So I can change this to pi by 4 minus x when I simplify it. Similarly, in the denominator we can change this to cos of pi by 4 plus a. Now this can be written as sine of minus x, which is minus sin x, correct? So this will be, just to give you an example of how we can do this, minus 1 times pi by 2 minus x minus 2x by 2. So this is equal to minus 1 by m. Now I can change this to sine of pi by 4 plus a times cos of pi by 4 minus x by cos of pi by 4 plus a. Now this will be minus sin x. So minus, I put the minus here, sine of pi by 4 minus x, which is equal to minus 1 by m. Now we have negative on both the sides, so we can change this to plus, because there is negative on both the sides. So we can cancel out the minus 1 actually. Okay, now let's see the ratio. So this is sine by cos, the first part. So this is tan of pi by 4 plus a multiplied by, now this is cos by sine. So this is 1 by tan or cotangent. So I'll write it as 1 by tan so that it's easier to apply the proof. So this is tan of, sorry, it is Yep, it is tan of pi by 4 minus x. This is equal to 1 by m. Correct? Now m is equal to tan of pi by 4 minus x divided by tan of pi by 4 plus a. Now what I can do is, this is tan of pi by 4 minus x multiplied by cot of pi by 4 plus a. Now what is the required proof here? Let's go back to the question. So in the question, the proof required is tan of pi by 4 minus x times tan of pi by 4 minus a. This is equal to m. So what I'll do is, because I need tan on both the terms here, I will change this cotangent to tan by applying the logic. M is equal to, let me rewrite this equation. This is tan of pi by 2 minus pi by 4 plus a. Because tan of pi by 2 minus x is cotangent or cot x. So now m is equal to tan of pi by 4 minus x times tan of pi by 4 minus a. So this is how we can apply the trigonometric functions in different quadrants logic here and arrive at the proof. So please solve questions like this so that you are very well versed with applying the logic of ratios as well as trigonometric formulas, and then you will be pretty good in solving any proofs. Thank you so much for watching till here. Please share this with your friends, and I'll see you in the next video.